Okay, let's graph some trig functions. So what do I mean by a trig function? So a trig function is going to be a function where the input value are the theta angles. So the angles off this circle, 0, 30, 45, 60, and so on. The output, of course, then will be sine of whatever angle we plug in if we're graphing sine. So let's see what happens. So let's find the initial value. So let's plug 0 in for theta. Okay, so if I plug 0 in for theta, I'll have f of 0 degrees is equal to the sine of 0 degrees. Of course, remember the sine is the y value of these points. So 0 degrees here, this point is 1, 0. So the sine of 0 is 0. All right, let's do the really easy points first. So let's do the sine of 90 degrees. So f of 90 degrees is equal to the sine of 90 degrees. Oops, forgot to answer that one. The sine of 90 degrees, so we look here, we're looking for the y value of this point, which is 0, 1. So the y value is 1. Sine of 90 degrees is 1. So if we plug in a 90, we get a 1. All right, let's plug in 180 degrees. So the sine of 180 degrees, we'll look at 180. Of course, the y value of this point is 0. So we'll plug that in or plot that point. All right, 270 degrees. So we're looking here on the unit circle. The y value of this point is -1. So the sine of 270 is -1. All right, 360 degrees. So 360 degrees is all the way around the circle. The y value of that point is back to 0. And of course, we can keep on going around the circle, so let's do 450 degrees. So 450 is one trip around the circle and 90 more degrees. So the y value of 450 degrees would be 1. So we're back up here. And you can see that this pattern will start repeating over and over. So once we get to 360, we went around the circle once. And now we're just going to go around the circle again, so we should get the exact same pattern as before. The next point will be 540, it'll be at 0, and so on. All right, if we go this way forever. Okay, so -90 degrees. So remember, negative angles going clockwise. So -90 degrees would be this point. The y value would be -1. And of course, that pattern will repeat. -180, the y value would be 0. So we would be back up here again. And you can see you keep getting the same pattern over and over. All right, so let's think about the domain and the range. All right, so what's the domain of this function? Remember, domain is all the x values you can plug in. Or in this case, all the theta values that you're allowed to plug in. So since we can go around the circle as many times as we want, and we can go backwards and get negative angles, we're going to be allowed to plug in any theta value or any degree angle we want. So the domain would be all real numbers, from -infinity to infinity. What about the range? Okay, so the range is a set about all outputs of the function. Okay, so our range obviously never goes below -1 because no point on this circle has a y value below -1. No point on this circle has a y value above +1. So my range has to stay between -1 and 1. And both of those are included, so we'll use square brackets. So there's my range from -1 to 1. And we'll see that you actually do get every point in between -1 and 1. Right now we only know a few points in between, but they're all there. All the y values get taken on. All right, let's find some other points here. So the ones in the middle. So I have 30 degrees, 45 degrees, and 60 degrees. Again, make sure you have these spaced approximately correctly. 45 is between 0 and 90, exactly halfway between 0 and 90. Make sure your 30, though, is not exactly between 0 and 45. 30 is not halfway between 0 and 45. 30 is 15 degrees from 45, but it's 30 degrees from 0. So make sure those are spaced approximately correctly. All right, what's the sine of 30 degrees? Okay, so we look at our circle. Here's 30 degrees. The y value is 1/2. So if I plug in a 30, I get 1/2 right here. All right, 45 degrees. The sine of 45 degrees is the square root of 2 over 2. I've asked my calculator to give me an approximation to that. The square root of 2 over 2 is about 0.707. So let's put that, go about right here. Get that point. All right, let's do the sine of 60 degrees. That would be the square root of 3 over 2. My calculator told me that was about 0.866, which would be about right in this area. Look at that. All right, let's do some more angles. So we have these next three, which are 120, 135, and 150. So 120 degrees, 135 degrees, 150 degrees. Plot those points. So the sine of 120 degrees, the y value would be the same as this point, so it would be the square root of 3 over 2, which is about 0.866. So we get this point straight across from this one. 135 degrees, sine of 135. Matches up with this guy. The y value will be the square root of 2 over 2, which is approximately 0.707. So that goes there. And 150 degrees would match with this point. It matches up with the 30 degrees. So it should be exactly across from this one, about right here. All right, let's do these three in the third quadrant. So 210, 225, and 240. So 210 degrees, the y value matches up with this one, which matches up with this one. So it's 1/2, but since it's in the third quadrant, it would be negative 1/2. There's negative 1/2. So that goes here. 225. Matches here, matches here, matches here. So it's negative square root of 2 over 2, or negative 0.707. So about here. 240 degrees. Matches up with this, which matches up with this. So it would be the square root of 3 over 2, except it would be negative 0.866. About right in there. That. And then you can guess what's going to happen with these next 3 points. We have 300, 315, 330. Okay, so of course 300 matches up with this point, which was 240. So it should be, except it'll be negative, just like it, so it matches up at that point. 315 will go straight across from this point, and 330 will go straight across from this point. And then we start back around the circle again, so you know exactly what it's going to look like. Okay, so these are all the points we're able to find right now course, we could find the same matching points on out. But every point in between there actually exists. We'll learn how to find those later on, things like the sine of 15 degrees. So our graph, we're able to connect these dots, and our graph looks like this. Notice that in the first two quadrants, quadrant 1 and quadrant 2, my graph is concave down. In this next quadrant, it's concave up. I just missed every dot there. When you miss your dots, cheat a little bit like that. Right, so it should be concave up on this interval in the third and fourth quadrants. Make sure when you draw your graph that it's properly concave. Concave down, concave up. And then it switches again. Now it's concave down. And it keeps doing that forever. Over here, you would get the same thing. This will be concave up. And you get this nice wave that repeats the same pattern over and over and over forever. All right, let's graph the tangent of theta. All right, so let's start with the initial value, and let's find tangent of 0 radians. So 0 radians here, tangent is y over x. So we have 0 over 1, which is 0. Let's do the easy points first. Let's do pi over 2. So what is the tangent of pi over 2? Pi over 2 is 90 degrees. So y over x, that's 1 over 0, which is undefined. Okay, so we're not able to plot that point. Now let's do the tangent of pi. Tangent of pi is here. Y over x. So let's see, that would be 0 over negative 1, which is 0. So the tangent of pi would be 0. Tangent of 3 pi over 2. That's y over x for this point. My x value is 0, so this will be undefined, so we can't plot that point. All the way around to 2 pi, the tangent of 2 pi, y over x, 0 over 1 is 0, so we can plot that point. Now let's go in the opposite direction, negative pi over 2. So we rotate this way. We're here. This one was undefined because the x value is 0, so no point there. Negative pi is here. 0 over negative 1 is 0, so we can plot that point. Negative 3 pi over 2, that's up here. That's undefined because my x value is 0. Negative 2 pi, that's all the way around the circle. 0 over 1 is 0, so we can plot that point. All right, so we plotted all the main points, and we know almost nothing now about what the graph looks like. We've just got some points there on the x-axis that don't tell us a whole lot. So let's graph some more, see if we can figure out what's going on. So let's do pi over 6. Remember, pi over 6 radians is 30 degrees, so we're looking at this one. So the tangent of pi over 6 is equal to 1/2 over the square root of 3 over 2, which is 1/2 times 2 over the square root of 3. 2's cancel. I've got 1 over the square root of 3. I need to rationalize that denominator. So I'm going to multiply by the square root of 3 over the square root of 3, which gives me a 3 on the bottom and a square root of 3 on the top. Okay, so let's see if we can write that somewhere. All right, so the tangent of pi over 6 is the square root of 3 over 3. All right, which is about, I asked my calculator this, it's about 0.577. So that would be here, that point. All right, the tangent of pi over 4. Well, that's the tangent of 45 degrees. y over x here gives me 1, so that one's really easy. All right, tangent of pi over 3. Okay, that's 60 degrees. So we have y over x, that's the square root of 3 over 2, times, we're divided by 1/2, so times 2 over 1. That cancels, and I get the square root of 3. So the tangent of pi over 3 is the square root of 3. Square root of 3 is about 1.73, which would be right in this area. So now we're getting somewhere. All right, let's look at these values. So negative pi over 6, negative pi over 4, negative pi over 3. So if I go negative pi over 6, I'm looking at this angle, which should match with this one, except now my value will be negative because my y value is negative and my x value is positive. Right? The signs are different in quadrant 4. So when I do y over x, I'll get a negative answer. But it'll be the same as the tangent of 30, except it's negative. The tangent of 30 degrees was this, square root of 3 over 3, which is 0.577, except it's negative. Put that over here. So that point will go there. All right. Let's do negative pi over 4. So that would be this point, which matches with this point. The tangent of 45 degrees was 1. So the tangent of 315 will be negative 1, again, because the signs of my x and y are different. Okay? The y is negative, the x is positive, so when you do y divided by x, you'll get a negative answer. So it should be the same as the tangent of 45, which was 1, but now it's negative 1. Right, so plug that in, that point. All right, negative pi over 3. Okay, so that's right here, matches with this one, which was the square root of 3, except now it'll be negative, so negative 0.173. So about here. So that's what that looks like. All right, let's go out to maybe this value. Okay, so this is the first one that we know past pi over 2. So we're talking about 120 degrees, which should be the same as this one, which is this. Except this time my answer will be negative because in the second quadrant, my y is positive and my x is negative. So y divided by x is negative. So I'll get a negative, whatever I got here, which was that, so negative 0.173. So that goes here. All right, the next one, 135 degrees, matches with this one, which is 1. Tangent of this is 1, except here it'll be negative 1. So we get this point. And then the next one would be this, which matches with this, except it's negative. So square root of 3 over 3, which is this, except it's negative, so negative 0.577. So that goes here. And you probably can guess now what's going to happen in this quadrant. First of all, think about, will your answers be positive or negative in the 1, 2, 3rd quadrant? So in this quadrant, will tangent be positive or negative? Well, in the 3rd quadrant, both my x and my y are negative. Negative divided by negative is positive. So the tangent values will be positive here. So this one matches with this one, which matches with this one, which is this, except it's positive. So it'll be positive 0.577. here. And then the next one will be 1, and it's positive. And then the next one would be this guy, which matches with this guy, which matches with this one, which is this. So it's a square root of 3. It's 1.73. So we've graphed enough now that you can see what's going on. At these points where the tangent was undefined, we have a vertical asymptote. So vertical asymptote here, 3 pi over 2. And we would have another vertical asymptote out here at, let's see, 2 pi plus another half pi. That's 2 plus 1/2. That's 4 over 2 plus 1. This would be 5 pi over 2. We'd have another vertical asymptote. Okay, and then the same thing over here at the points where it was undefined at negative pi. No, wrong one. It's not undefined there, it's 0 there. It's undefined at negative pi over 2. And negative 3 pi over 2. And then out here at negative 5 pi over 2, we would have another vertical asymptote. All right, and then this pattern keeps repeating over and over. We have this. Make sure it goes down that asymptote, up that asymptote. Same thing here. Down this asymptote, up this asymptote. Same thing here. Down this asymptote, up this asymptote. Same thing on this side. Up this asymptote, down this asymptote. Up this asymptote, down this asymptote. Like that. So there's a graph of tangent. All right, let's talk about the domain and the range. So the range is all the outputs. Notice that tangent can take on any y value it wants. It goes up this way forever, down this way forever. So the range is from negative infinity to infinity. All right, what about the domain? All right, so the domain is all real numbers except some. There's some of them we can't plug in. We can't plug in 0, half a pi, 3/2 of a pi, 5/2 of a pi. We can't plug in negative pi over 2, negative 3 pi over 2, and so on. So your domain be all real numbers except, all right, now how can we write this out? So let's do it like this. This seems to make sense. So forever in this way, we're going to have negative 5 pi over 2, undefined. Negative 3 pi over 2, undefined. Negative pi over 2, it's undefined. Pi over 2, undefined. 3 pi over 2, undefined. 5 pi over 2, undefined. And on like that forever. Okay, so notice all the places where it's undefined, we have a 2 in the denominator and a odd number in the numerator. So always 2's, and then you have 1, 3, 5. The next one would be 7 pi over 2, 9 pi over 2, 11 pi over 2, and so on forever that way.